All right, today we are going way beyond just the code. We're talking about a full-blown AI industrial revolution. This is a massive shift from abstract ideas to a physical reality that is being built right now as we speak. We usually think of AI as this invisible code, right? Something just floating around in the cloud, totally intangible. But the next huge leap for AI, it's all about atoms. It's about the raw physical infrastructure that's going to power everything. So let's kick things off with the world of atoms. We're talking concrete, power plants, factories, the sheer physicality of what it takes to bring this next generation of AI to life.
Okay, get ready for this number. $20 billion. No, that's not the budget for a small country. That is the reported price tag for one single data center project from Microsoft and OpenAI called Stargate. This is not just another server farm. It is a declaration of the insane scale of ambition in this AI race. A facility like this is literally designed to house supercomputers that will train AI models that are orders of magnitude more powerful than anything we have today.
So how in the world do you power a $20 billion AI brain? Well, you give it its own nuclear power plant, of course. Projects like Stargate are being designed with integrated small modular reactors, or SMRs, to achieve what they call energy sovereignty. What does that mean? It means constant, clean power, totally separate from the public grid. Because for these systems, you just can't have blackouts. There's no room for error.
And here's where things start to get really, really wild. In these new AI factories popping up in Vietnam and Mexico, NVIDIA and Foxconn are actually using AI to build the hardware for the next generation of AI. They create this perfect digital twin of the entire factory, and then AI agents figure out the absolute most efficient way to automate the assembly of these incredibly complex server racks. It's this crazy feedback loop. AI is literally building its own body. Okay, so you've got this unprecedented power, you've got the automated factories. What's the next piece of the puzzle? The chips themselves. We're seeing this major shift away from just general-purpose chips and toward highly specialized, custom-built hardware. When you put it all together, you see this brand new vertically integrated supply chain emerging. It's a total game changer. You've got Microsoft and OpenAI locking down their own power supply with SMRs. You have NVIDIA and Foxconn automating hardware assembly with AI. And then you have OpenAI working directly with TSMC to create its own custom chip, the Sovereign One, designed specifically for AI reasoning. Companies are not just buying parts off the shelf anymore. They're building the entire stack themselves. And why? To control their own destiny, to optimize every single component, and to gain that critical edge in the race for AI dominance.
All right, so all this incredible hardware, this world of atoms, it's all built for one reason: to unlock some absolutely mind-bending software capabilities. So let's flip the script and dive into the world of bits.
So let's talk about memory for a second. Until very, very recently, the best AIs had what's called a context window. Think of it like their short-term memory of about 128,000 tokens, which are basically just little pieces of text. Now that's enough for the AI to read and remember a single large book at a time. Pretty impressive, right? Well, that's about to seem absolutely tiny.
So you remember that one large book we just talked about? Well, Google's new Gemini 3 Pro model, it has a context window of 5 million tokens. This is not just an upgrade, it's like a jump to a completely different dimension. We're talking about the ability to process and remember the equivalent of an entire encyclopedia, or dozens and dozens of novels, all in one single go.
And it gets crazier. It's not just about a huge short-term memory. There's this new feature called active memory, which means the model doesn't just wipe the slate clean when you're done talking. It can hold on to the context of your conversations for weeks, even months. Imagine you're a developer. It's like having an AI partner with a perfect, persistent memory of every line of code, every decision, every single detail of your project. And this is the kind of superpower it unlocks. Look at what Anthropic is doing with its new Enterprise tool. It can take that massive memory and basically create a visual map of an entire code base. Just like the quote says, a developer can make one tiny change and instantly see the ripple effect across millions of lines of code. It turns a task that was basically impossible into something you can see and understand visually. But whenever you get this kind of godlike power, both physical and digital, you're going to run into some new and incredibly complex problems, the kind of stuff we've literally never had to think about before. So what happens when these systems start interacting out there in the real world? Okay, take this idea of agentic collusion, which the security firm Wiz flagged. Now, this isn't some evil AI plot from a sci-fi movie. It's a perfect example of a totally new emergent problem. It's what happens when you have thousands of autonomous AI shopping agents all just trying to get the best price for their users, and they accidentally start coordinating. By learning from each other's bids, they can, without any malicious intent, create a situation that looks an awful lot like illegal price fixing. It's a problem of optimization, not evil intent.
So when new tech creates new problems, what happens next? Well, society has to create new rules. The question is, how are we even beginning to govern these incredibly powerful and autonomous new systems?
One of the first real attempts at this is coming out of California with their Agent Transparency Act. The problem was pretty clear. You have these AI agents making decisions for you, but they might be getting hidden commissions and their logic is a total black box. So this law says that if an AI is booking your travel or buying you stuff, it has to tell you who built its logic and whether it has any financial incentive to push one product over another. It's a really crucial first step towards accountability in this new autonomous world.
So let's recap. We've seen the atoms, the reactors and factories giving AI a physical body. We've seen the bits, these insane, planet-sized memories and an almost godlike understanding of complexity. And we've seen the rules, our first baby steps to try and govern it all. This leaves us with one final and absolutely crucial question. As we build AI its own factories and its own power grids, who is ultimately in charge of the future it creates?